everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. It comes from the educator side of the SAT people. And just a spoiler alert, this question could appear on a Blue Book test. Okay, a number x is at most 2 less than 3 times the value of y. If the value of y is -4, what is the greatest possible value of x? Okay, I've been making a lot of mistakes recently, so Seth, take it away.
Okay, I have two ways of solving this problem.
Okay, good.
Way number one is to think and talk about it in English. Now, the problem is to find the greatest possible value of x. Well, the data says that x is at most something they tell you. So, the greatest possible value of x is the number that it is at most of. The number that it's at most of is 3. The number it's at most of is 2 less than 3 times y. So for x to be the greatest value, x has to be equal to 2 less than 3 times y. Okay, what is 2 less than 3 times y? Well, you need to know what 3 times y is. Well, they tell you what y is. 3 times y is -4. No, sorry. You need to know 3 times y. What you need to know y is. Y is -4. So 3 times y is -12. And the answer is therefore 2 less than -12. Oh, this is a little tricky. What's -12? -12 is a certain negative number. To be less than it, you need to be more negative. And you need to be more negative by 2. So that reasoning expressed in English tells me that the answer is -14. Okay. Now,
yeah. By the way, let me
approach number 2 is to do it.
Let me make a comment. I like the way you did not write any equations. That's not the way I would have done it. I would have done more methodical with equations, but I like the fact that you just thought it through without writing anything down.
Okay.
That's good. That's good.
So now let's write things down using equations.
Now we're going to do approach 2.
Approach 2 is the way you like. But I'm not writing equations. I'm writing inequalities.
I know. I always make
so it's inequalities we're doing.
I know.
Okay, not equations. Not everything is an equation.
I know.
Yeah. Okay. So x is at most something. So we express that by saying x to be at most something is to write less than or equal to the something. Now, what is that something? That something is 2 less than something else.
Right.
So it's something else minus 2.
Yeah.
What's that something else? That something else is 3 times y.
Yep.
So there's our inequality that expresses the relationship between x and y.
Yep.
Okay. Now they tell you the value of y equals -4. So we evaluate this this right-hand side by substituting -4 for the y and do the arithmetic carefully with the signs. I get -12 minus 2 is -14. And then, so what we've derived is that x is less than or equal to negative 14.
Yep.
So the largest it could be is right at the boundary, negative 14. So
Yep.
I get negative 14
Yep.
is the answer solved by the translation to the algebra of inequalities.
Yeah, that's great. Yeah. That's very good. By the way, if you made a mistake, there's this thing that it says here at most, so one may think there's a greater than sign, just because most means, I don't know. You may just totally mess up the direction of
Well,
the
that's a
inequality
mistake
sign.
that's avoidable by studying. So
Yeah,
I
but
reviewing these, and I say at most, people will, Joel, I think you're prone to make that mistake.
I
And so
am.
you have to be aware when you say at most, you have to be very careful.
Yeah, but if you make,
And
but,
think about it, and you need to know, well, okay, say x is at most something. Does that mean x is greater than or equal to something, or less than or equal to something?
yeah,
And
that's
then you have
right.
to think at most.
Exactly.
That means it cannot be more.
You have
That
to
means it's
stop.
less than or equal.
Yeah, you have to stop and think. You have to stop
Yeah,
and
and say
think.
most.
Right.
Okay,
But
so okay, Joel, what if you want to say z
wait, I didn't finish
is
my thought.
z is at least a million?
That
How do
means
you write
Z has
that?
to be 1,000,000 or greater.
Yes.
Yeah. But wait, but you didn't let me finish my comment. You let me finish my comment. It's very easy. I mean, if you're not careful, you could get the inequality sign wrong. But even if you get the inequality sign wrong, the number 14 is still sitting here. So you could still say negative 14 and still get the right answer. Because then you could say the greatest possible value of x. You could sort of ignore this and say, well, greatest, oh, look, greater than. And you can make two mistakes in the same problem. They counter each other, and you would still get the right answer. You would still say negative 14, even if you got these signs in the wrong direction. Not a great way to do math, but you would still get the right answer. You would still say negative 14.
Mm-hmm.
So, but don't, obviously, you're just lucked out on that. But yes, you have to be really careful with these at most, at least, no more than, no less than. Oh, yeah, those are really nasty words that you need practice on. But basically, we all make the mistakes and we learn from them. And then there's this two less than, which is one of the worst translation problems that you basically start in sixth and seventh grade, and everybody makes the mistake by putting the two on the wrong side. But it's when you see a two less than, it's minus two, not the other way around. I'm sure everybody has made that mistake. Seth, when you were in little sixth grade, little Sethy in sixth grade, did you ever put the two in the wrong spot when you said something was a number?
Yeah, you
Yeah,
always put twos in
we
there.
all we all do it. We all do it because it says two less than.
Okay. Yeah, I have another example of misreading.
Okay, go ahead.
To misread two less than something. A possible misreading is then to write two minus.
I know that's what we just were talking about.
I don't think so. Do you
Yeah,
really?
that's what I
Two
was
minus.
referring to, but I didn't want to say it. I don't want to say it because I didn't want to plant bad things in people's heads. So I didn't want to say it.
Well, you already planted bad things in your head when you said it most is greater than or equal to.
That's true. That's true. That's true.
So I'm following your sin.
That's true. That's true.
Two sinners.
Fine. So we'll put it in a big. We'll put it in a very unattractive color.
Don't yeah, don't
color.
even say yeah.
So this is
yeah,
like
yeah.
I don't know. I don't know what's an unattractive color.
But
yeah,
but it's confused because when they say two less than something,
you put it in right. Yeah, two.
It was the two is on the left in the English, but in the algebra, the two is on the right. The minus sign.
I know. Yeah.
But if you said two more than something, It's okay to put it on the left.
Right. Yeah, because adding doesn't matter when you add. You
Adding is commutative.
adding is
Yes.
commutative, right? So it doesn't matter.
Yeah.
Yeah. Yeah. Yeah. Yep. 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 That's right.
Ah.
That's right. Okay. So by the way, today's first.
Adding is commutative means that it doesn't matter which order you add things.
Right.
That's what
Exactly.
commutative means.
Okay, so yeah. Anyway, I'm sure every single person in the world has made the mistake the first time they've seen it in fifth, sixth, or seventh grade, where they when they do a two less than they put the two minus or the minus two or the two minus in the wrong spot. Okay, so let's see what are the let's go over the. Oh, by the way, today is Thursday, so we're going to do a throwback Thursday question from a test from 20 years ago to get a sense as to what tests were like back then. And let's ask our questions. Calculator. No, calculator doesn't help at all in this. No, not really, unless you needed to do 3 times negative 4. Starting with the guess, not applicable. It's not a multiple choice question. This is a free response. How does this differ from a question in school? No, it could be answered. This question is valid. It could be answered. The question could be given in school. Is there a pattern to this question? No, there's nothing special here that's special. Special that makes you do it faster is the main idea is certainly translating English into math on inequalities and understanding dealing with these at most things this language related to inequalities, which you have to be very careful about. These are confusing. Think about it carefully, and also being careful about this two less thing. And then I guess either they're trying to see how good you are, what your skill level in translating English into math and solving, and also an understanding and not being scared to just substitute. Because once you write the equation, the skill of substitution comes in, where you substitute for y, you substitute negative 4. And of course, reading the question, the skill of reading the question comes in. So there are a bunch of skills that this question requires. Okay, so let's see how they did it. I bet they did it very similar to how Seth did it. Okay, let us see that. I'm just going to have to move us all around a little bit here. Just excuse us. Negative 14. Okay, cute little answer here. So let's put us back there. Okay, the correct answer is negative 14. It's given that a number x is at most. Okay, therefore x is less than or equal to 2 less than 3 times y. Right, the expression 3y, 3y minus 2 represents 2 less. They're saying the same thing, but they're saying it, they cost very wordy and a little long. Therefore, x is this. Therefore, so that's it. Yeah, so it's very standard. Very standard. Okay, anything more to be said?
Yeah, that's good.
Nothing more to be said. Okay, so today's Throwback Thursday. So we are going to go back and we are going to find the Throwback Thursday question, which is this one. And maybe the easiest thing to do is to go like this. Oh, that's nice. That's nice. Seth, let me tell you where we're the workspace that we have today. We have today going from this. I'll make the box. Okay, so there we go. So you could write in this box. Got it? Oh, okay. Okay. If m and n are positive integers and m is less than n, which of the following must be greater than m divided by n? This is what I would call a number theory problem. I don't really think they ask these types of questions anymore. So, they're positive integers. M is less than n. The way Seth's going to do it, because he does the PhD in math and he knows a lot more of number theory than I do. But the way I would do it is I would just make up a reasonable number for m, a reasonable number for n. Like I would make m be 3, and I would make n be 5, or maybe 7, and then I would test them. And that's how I would do it. I would do it through brute force, because I'm not a number theory expert. Yeah, I mean...
Make m 0 and n 1.
No, because you can get those are special cases. Wait, you can't make m 0 because something is a positive number. You can't make positive integers are not 0, so you can't do that.
Well, I like that idea. I like that idea. Sure.
Really? Really? I
Yeah.
mean, it's a risk because just because you've tested m to be 3 and n to be 7 doesn't mean it's true. You just may have lucked out. But being a non number theory expert, that's how I would do it. Really, Seth? You would do it the same way?
Well, I well, I did it a certain intuitive way involving ideas about how things change proportionally.
Mm. Mm.
And then I think I would have been happy if I realized that Joel's way of checking it is an excellent way.
Mm.
So would you like me to talk about how I tested it proportionally?
Why don't we get the answer first using my way? So this one here, so m, my God. So which of the following must be greater than m divided? So what is m divided by n? M divided by n is 3/7. So which of the following is greater than 3/7? So the first one, it's easy to make mistakes, is 4/8, 4/7, or 3/8. Oh wow! Now back then, I make a mistake?
Okay. 4/8 is a half,
4/8 is a half.
and 3/7 is less than a half because half of 7 is 3.5.
Right.
Okay. 4/7 is obviously greater than 3/7.
Right.
And 3/8 is less than 3/7 because the 8 in the denominator is bigger than the 7.
So the answer is only 2.
Yeah.
Yeah.
Oh, well, the answer is 1.
Wait. Wait. What? Wait.
4/8 is greater than 3/7.
Did I? Wait.
4/8 is 1/2.
Which of the following must be greater than? Oh, so this. Oh, so I got it. I did everything wrong. So this one is greater than, and
Yes.
this one is
So,
also greater than. Wait, four
yes.
sevens is also greater than 3/7,
Yeah, yeah.
and 3/8 is less than. Oh, so it's 1 and 2. So D.
Okay.
So the answer is D.
The answer is D. Yes.
The answer is D. Oh wow. Okay. This is okay. So that's a reasonable way to do the problem. It's not guaranteed because there could be something weird about 3 and 7. Not guaranteed and not proven for all cases, but it's probably good enough for this problem.
Okay. So let me explain how I approached it.
Go ahead.
Okay. Uh, First, I looked at the picture, looked at the answers,
Yep.
and I said, "All right, I'm not going to worry about 1 because that's too complicated."
Right.
Now, 2, well, they made the numerator bigger, which makes the fraction bigger.
Yep.
So 2 is greater than the original. 3, they made the denominator bigger. When you cut up the pie into smaller pieces and then give out the same number of pieces, then the recipient gets less pie. So this one is less.
Right.
But now what about this gadget?
So that's the trick. That's the one you have to
This
think
is
a little more.
okay. Here's the deal. Here's the
Go
deal.
ahead. Go ahead.
M is smaller than N.
Right.
So if you add 1 to a smaller number, the growth factor, the rate, the ratio by which it goes up, since it's originally smaller, the proportion that it goes up is bigger than the denominator number. the denominator number, you have a bigger n. So if you add 1, it doesn't make that much difference. It goes up, n goes up. N goes up when you add 1 to it, but it doesn't go up by as much of a ratio as a smaller number goes up. So therefore, the top goes up in a greater proportion than the bottom. Therefore, the ratio of the two uppernesses is greater.
Right. Yeah. Yeah. Right. Yeah. Yeah. So we don't know how most people would have done this. Wait. So can you prove that? Can you divide both numerator and denominator by m times n to sort of show that? If you divide
Oh
this
yeah, sure.
if you divide this by m times n and you divide this by m times n, you would get n plus 1 over m.
Yes.
And you would get
that works.
M plus 1 over n. Right? No. Wait. Mn. Wait, what am I doing? N plus mn. Oh, and 1 plus mn. Right. Right? Is that right? Yeah, right. Yeah, so that's what you would get. Now, n is greater. Oh, interesting. N is greater, so it's pretty obvious that, wait, if n is greater than m, then this, and then you're comparing it to m over n. I like the way you were thinking. And you're comparing the blue to the green. Which one is greater? Do you have any thoughts on that?
Yeah. What you did, you flipped it around. You're adding the same thing to the new. Something's wrong.
I'm dividing both sides by. I'm dividing numerator and denominator by m times n. I'm dividing everything by m times n.
So divide the numerator and the denominator by
m times mn, yeah.
No. If you divide m, no. The thing you wrote on the top of the bar should be 1 over n.
Yeah, right.
Yeah. Right. That doesn't work.
1 over n plus 1 over nm, and 1 over m plus 1 over nm. And you're comparing that to m divided by n. Yeah, okay, I don't know. This is a rabbit hole, right?
Okay. Let's see. Where can we write?
Right in the gray area.
In the gray. Let's try this. All right. Yeah, here we go. M plus 1.
Oh no, lower, right lower. Wait. Hold on, Seth. Hold on. Let's give you some legitimate space. Hold on. You deserve some serious space, okay? So just hold on. Let's make everybody smaller.
So should I write between the gray and the blue?
Yes. Yes.
Okay.
Yes. Yes.
So here's our m plus 1 n plus 1. Okay.
Okay.
So let's write that as n plus 1 divided by n times n, right? And then divide n plus 1.
Hmm. Clever.
Okay. Well, let me erase that. Okay. And then next to it, I'm going to put, I have to remember, now I put in the n plus 1. What do I do? No, I didn't want to do that. I meant not to do that.
So what we're doing here is we're
Hold on. Just
No,
let
I'm
me
not
talk.
talking to you. I'm talking to the audience. What we're just doing here is doing some algebraic tricks, manipulations, rewriting it in some algebraic way to make it so that we could use arguments to show that something is greater than something else or less than something else. But you need a lot of experience to know how to split this up algebraically. And that's Seth has the PhD in math, so he's done this before. That's an m plus 1, right? Yeah.
Yeah. Okay, very carefully.
Wow.
So the n's cancel and the m's cancel.
Absolutely.
And since nothing is 0, none of it is 0, you're okay. Now, so, this doesn't help.
No, but you're comparing it to m over n.
This is...
So that means you have to evaluate this thing.
Okay, we're comparing this to m over n. All right, so what happens? No, it doesn't work. Doesn't work.
This is what happens in math.
Sorry, it doesn't work. Because the n plus 1 over m makes it bigger. But the other one makes it smaller.
Yeah, but you told m is greater than m is less than m. So.
Yeah.
Okay.
So this idea, this idea doesn't work.
Okay, so it's going to take us too long to figure out how to do it.
Well, but if I translate my idea, I would say that how much m plus 1 changes, the change of m plus 1 over m is greater than n plus 1 over n. Right?
Right.
And therefore, the ratio of these two, m plus 1 over m and n plus 1 over n is greater than 1. All right? And then multiply top and bottom by m over n. Good, you're erasing that. Good. Finish erasing it.
Yeah, okay. I'm actually not erasing it. I'm covering it with white.
Okay, covered really well.
I'm covering it with white.
Yeah, good. So now multiply top and bottom by m over n. So I get m
over n or just m times n?
No, m over n.
Okay.
And I get that greater than m over n. So I could reach. Here's the conclusion
Very nice.
that we need
Very
to know.
nice. Very nice.
Now, why is the top equation true?
You got to justify it.
Yes, I got it. So to simplify,
I see how you can
simplify the left-hand side. We get 1 plus.
You're right over here.
Over.
So I'll write it. It's 1.
Yeah.
You need to write it here. It's 1 plus 1 over m is greater than 1 plus 1 over n, and that is true.
That's true because m is smaller
than n. Yeah, wow. So we've really justified it like in a very rigorous way, for us at least.
Yeah.
So this is the way mathematicians do things. They justify things rigorously after they have an intuition that that's the answer.
Yes.
So that's good. So everyone gets a little view as to how mathematicians actually work.
Yeah.
But in terms of actually doing the problem, you don't have time to be a genius. You just or a hard-working mathematician. You just take a chance and make up some numbers and see if it works.
Okay. Now let me show another approach.
Okay.
Which I don't think they use in school, and is not even done much in math classes.
Wait. So for that, let's give you let's give you some. Wait, hold on. I can't wait to see this. Wait, hold on. Let's clear all drawings. Okay, that gives you some nice.
So where can I write?
Virtually anywhere.
I write above the gray. No.
Right.
Just say no once.
There.
I'll write between the gray and the black.
Right there.
All right. So here we go. Where we are wondering whether m plus 1 over n plus 1 we are wondering. So therefore, put a question mark. Right? We don't know, so put a question mark there. And then you do transformations that preserve inequalities.
Okay.
One of these transformations is to multiply both sides by a positive number.
Got it.
Now, let's do it twice. Right? Let's multiply both sides by n plus 1. Let's see. Yeah, and multiply both sides by n.
Okay.
So what's the result? M plus 1 times n. Say keep the do I wonder which is bigger. M times n plus 1.
Right, yeah.
Okay.
Oh, that is a really smart way of doing it. Wow.
Then you multiply them out with your distributive law.
You can have m's on both sides.
Mn plus n.
Right.
We wonder if that is greater than
mn plus m.
mn plus m.
Right.
And we could subtract.
Yeah, you just subtract m
times n from both sides and wonder if n is greater than little m. Now, since the inequalities are preserved, we could now take what they told you. N is greater than m. So this question mark, we could change that question mark to true.
Yeah.
And therefore reverse this step. And this is true.
Right. Uh-oh. I think Seth froze. Oh no! Come on. Seth froze. So we see what happened. Yeah. So we're basically So then Seth's gonna say we reverse the steps. We go back up, and Seth froze on Zoom. Okay. So I think that's it. Seth basically is going up this way. So this is true. So this is true. Okay, we better stop. So anyway, I have a PhD in mechanical engineering. My brother says a PhD in math. We talked about that before. He knows a lot more number theory and algebraic manipulations than I do. So I'll just finish off here. So where this is SAT math question of the day, we go through a SAT math practice question once a day. On Thursday, we do Throwback Thursday. We have different approaches, so we take different views. We try to use different. Here comes Seth. Okay, here comes Seth again. Hi, Seth, you're back. We lost you. Okay, you're muted. Okay, so Seth,
Hello again. Hello,
I'm finishing
back.
off. I explained how you just go up and then you get it. Yeah.
Okay, we're done.
Yeah, we're done. So I was just finishing off that we try to go through the problems and offer different approaches, different methods. While we don't know what's on the test, we know that these approaches and methods are going to be useful on the test you take, and you should take as many practice tests as you can. We've heard Blue Book 4 and Blue Book 6 on the math side are the closest to the actual SAT. Practice on those. If you're not sure of any topics, go to the Khan Academy digital website and practice on those, and also practice on the topics you're strong on, so you can do those faster, so you have time to do the questions that are more challenging. And then please dislike our videos, and we hope to see you tomorrow.
I have one more math comment to add to this.
Okay, go ahead.
That technique of putting a question mark next to a relation and then deriving equivalent relations by operations that preserve them, that is an important technique in high school math for proving identities. Trigonometric and otherwise, trigonometric and algebraic identities. That's a good way of proving an identity. What you do is you reduce it to an obvious identity like 1 = 1.
Right.
And then you do transformations. You must make sure transformations preserve. In particular, you don't multiply both sides by 0.
Right. Yeah.
So that's taught in. I don't think they do that. That's not covered in the SAT.
Right. Okay, I think we're done. So we got a little a taste of how to do algebraic manipulations for number theory questions, which is great. Okay, I guess we're done for today, right? Okay, I hope everyone got something out of today, both the regular question and the throwback question from 20 years ago, at least 20 years ago. Okay, everyone, have a great day. Bye-bye.
Okay, bye.